The atmosphere is the envelope of gases surrounding our planet. Now, Earth's atmosphere is mostly nitrogen, with about 21% oxygen, and then 1% of all of the other gases, such as carbon dioxide, methane, nitrous oxides, sulfur oxides, and all the other gases that we'll talk about during this series of lectures. Now, the atmosphere is not all the same thickness. It doesn't all have the same amount of atoms in it. Because gravity pulls things down towards the Earth, there are more molecules in the atmosphere near the ground than there are as you move away from the planet. Now, because of its different properties, scientists have given the atmosphere different striations. Part of the atmosphere closest to the ground is called the troposphere, and this is the thickest part of the atmosphere. This is where most of the molecules are. Gravity has pulled down all of those atoms down towards the Earth. So the troposphere is the part that you and I walk around in. It's the part that weather happens in. The next layer up is called the stratosphere. And the stratosphere is much thinner in the amount of material that's in it. But one area that is incredibly important is the ozone layer. And this is sometimes called the oxygen ozone layer. This oxygen ozone layer acts as a barrier to ultraviolet light and shields our planet from high-intensity ultraviolet light that has a very damaging effect on animal and plant DNA. You don't need to know every single atmospheric layer. You don't need to know all the minute details about the layers of the atmosphere. You really need to know that the part we walk around in that has the weather in, and therefore that concentrates our pollution, or air pollution, is the troposphere. And you need to know that the next layer up is the stratosphere. Stratosphere contains the ozone layer. Air pollution is a very taxing problem, and one of the reasons that it's so difficult to get a grip of is that it is not a local pollution event. If you have an oil spill, that oil spill tends to be a localized event affecting the area where the oil is spilt. The problem with air pollution is the air is not still. It doesn't stay in one place. It moves quickly and moves long distances around the planet. So we don't have local air pollution problems. We have global air pollution problems. Right here in Georgia, we're getting our air from parts of Florida often. So if Florida has a forest fire, right here in Milledgeville, Georgia, we can often smell the smoke from a fire down in Florida. The air is moving over the surface of the planet, carrying with it that air pollution. So that makes legislation much more difficult. It means that this area of Georgia isn't solely responsible for the quality of its air. Florida is responsible for it, and Mexico is responsible for it as well. So the atmosphere is moving around the planet. Why is it moving? And you already know that it's moving because of wind. So why does the wind blow? Now, we talked really briefly about that, but let's go over it again. The Earth absorbs energy from sunlight. And when it absorbs that energy from sunlight, a lot of the energy is converted into heat. Heat causes the air to expand. It becomes less dense. As the molecules move apart, as the air expands, there's less molecules in the same amount of space, so it's less dense. Being less dense, it rises into the sky. So that air, less dense, rises up into the sky. And as it moves up in the atmosphere, it radiates some of its heat back down into space. So it starts to cool. And as it cools down, the molecules move closer together again. It gets more and more dense, and as it reaches a higher density, it gets heavier, and it sinks back down towards the Earth. Now, this doesn't happen in one place, because the Earth is spinning on its axis every day. So that air is moving over the surface of the planet as well as going up and down. So this up and down movement of air, combined with the spinning of the planet, causes our winds to blow and carries our pollution around the planet. So on weather maps, you've often seen pictures of high pressures and low pressures. As our air expands and becomes less dense, it becomes a low pressure zone, and that low pressure zone is air lifting up into the atmosphere, moving away from the troposphere towards the stratosphere, generating a low pressure zone. Where we have colder air dropping down into the troposphere, as that air condenses, as that air gets closer together, its density increases, and as that high density air drops down towards the surface of the Earth, we've got a high pressure area. So air is then flowing from high pressure zones to low pressure zones, carrying air pollution with it, causing the winds, and distributing that air pollution over large areas of the planet. The amount of air pollution found in an area really depends on two main factors. One is the population of that area, and the other is the industrialized nature of that society. The more industrialized or technological a society is, the more industry it has, the more energy it uses, and the greater the air pollution produced. Obviously, the higher the population, the more people there are in that area, the more air pollution that you find. So if you combined increase in population with increase in technology, such as becoming a much more developed country, air pollution problems become more astute, become more concentrated. And as all these people start using their fossil fuels to drive cars, or using large amounts of electricity to run their computers and their TVs, that air pollution has an impact on their lifestyles. Not only does it have health impacts, where it may cause health problems, breathing problems or eye problems, it also has a cost problem. If we're going to improve air quality, then we have to put in technologies that prevent pollution, and preventing pollution is going to cost money. So it's quite easy to develop an industry to generate electricity. Burning coal's not very difficult, boiling water's not very difficult, generating the parts to actually convert steam into motion so we can spin a magnet and get electricity is not technologically challenging, because you can go on the internet and look up how to do it. Doing all of that without producing air pollution, that's technologically difficult, without degrading your environment. And a classic example of this would be London. If you watch old movies, particularly old Sherlock Holmes or Jack the Ripper type movies, London in the Victorian era is always shown as being filled with fog. It's a completely foggy city. And most of that is not, in fact, true fog. Fog being just clouds that are at ground level. A lot of it is smog. It's produced by burning large amounts of coal and burning large amounts of oil in a very, very dense population, and that fog, that smog, is just produced within the city, can't get out of the city. The number of people burning coal fires, the number of people burning oil lamps is dramatic, and it has a huge impact on the air pollution. So big society trying to become technical, trying to become more developed, going into the industrial era, producing large amounts of air pollution. And then as we move towards the 21st century, not only does our technology become better, but our ability to produce those goods with less air pollution also becomes better, but at a cost, at a financial cost, that as we clean up our act, it does physically cost us more. The problem with growing population also is that air cannot be diluted as it moves from one area of the country to another, or one area of the world to another. We already said that Georgia gets a lot of its air from Florida, and they got it from Mexico. So as the Mexican population increases and they add air pollution to that air, as the Floridian population increases and they add air pollution to that air, when it then gets into Georgia, the air is already loaded with pollution, and as our population grows, we add more pollution to it. Ultimately, the air is getting saturated with pollution, and dilution is not removing those pollutants before the next people need to use the air. We definitely see that in the United States up near Chicago, where industrial areas of Chicago are adding pollution to the air, and rather than it getting diluted and spread out, the air is passed over city after city. Each city adding more and more pollution to the air until that polluted air reaches Canada and causes acid rain problems, causes smog problems in areas of Canada that don't have a huge population. So as the population grows, it's adding concentrated pollutants to the environment. Normally with a smaller population, because of the movement of the air, it would have diluted those pollutants down and they would have had less of an impact. As the world population grows, that dilution factor doesn't occur. All that happens is already polluted air is moved to the next city and they pollute it still further, that goes to the next city and is polluted still further. So if you live in an area where the wind patterns are bringing in air that's come from major industrial cities, it's carrying with it large amounts of pollution. Now here in Georgia we see that because the air is moving up from Mexico, it's moving over Florida, it's moving over Georgia, and it carries that polluted air up towards the Great Smoky Mountains. And when you go through the Great Smoky Mountains, there is an acid rain problem in that area where all of this industrial pollution then rains out, the air hits the mountains, it has to go up to go over the mountains, and as it goes up it gets cooler. That cooling causes precipitation of water. That precipitation of water becomes rain. The rain drops out, carrying with it large amounts of the pollution. So if you go up into the Blue Ridge Mountains, if you go up into the Smoky Mountains, you can see air pollution effects. Even though the industry is not right there, the effect of that air pollution is occurring in those mountain zones. Now, not every state has equal problems with air pollution. Some states produce much less air pollution than others. Highly industrialized states tend to produce more air pollution. Less industrialized or more agricultural states tend to produce less air pollution. Again, remember the problem though is not a local one. Because air moves, a state that produces large amounts of air pollution is not going to have to deal with it all on its own. Its pollution is going to be blown across the country and influence not only the United States but also places like Canada and the United Kingdom. Remember that there are two different types of pollution. There's anthropogenic pollution. Anthropogenic means coming from humans, and there's natural pollution. So for most of this lecture we're going to focus on the anthropogenic ones because they're the ones we can have an impact on. So as our activities through industry or our lifestyle are producing pollutants, we find that there are two different classes of pollutants: primary pollutants and secondary pollutants. Primary pollutants are chemicals that are polluting in the form in which they are released into the air. So when this chemical comes out of the tailpipe of the car or out of the smokestack of the industrial plant, it already is a pollutant. It's released in amounts that make it harmful, and it's in a form that is harmful. Now, make sure you've looked up what makes a pollutant a pollutant. We did that in one of the early lectures. I'm not going to go over it again because by now you should already know that. So primary pollutants come out where they're produced and are already pollutant. So the major ones you can see right here: carbon monoxide, VOx, volatile organic compounds, VOx, particulates, sulfur dioxides, and oxides of nitrogen. These last two, the sulfur and the nitrogen ones, they're often called SOx and NOx. So SO and with a small x, and then NO with a small x. That way you don't have to know the exact chemical makeup of them. We know that it's a sulfur oxide, which one doesn't really matter, or nitrogen oxide, again, which one doesn't really matter. Secondary air pollutants are made from primary air pollutants that react once in the atmosphere. So a primary pollutant will be released into the atmosphere, It'll undergo a chemical reaction and will produce a new chemical. That new chemical, if it's a pollutant, is called a secondary air pollutant. So we're not releasing these from the tailpipes of our car, we're not releasing them from the smokestacks of our industry. They're actually being made in the atmosphere from the primary pollutants. The last group of air pollutants that you need to know are called criterion air pollutants. Now, this isn't telling us whether they're primary or secondary. Criterion air pollutants are pollutants that have standards set for them by the EPA, the Environmental Protection Agency. So criterion air pollutants are measured by the Environmental Protection Agency and have a set standard where industry is not allowed to produce more than a certain amount of criteria air pollutant. So there's 6 criteria air pollutants in the United States. They are lead, nitrogen oxides are NOx's, VOX, VOX stands for volatile organic compounds, sulfur dioxides are SOx's, particulate matter, and carbon monoxide. If you burn a fuel efficiently, then that fuel will burn to produce carbon dioxide. If you burn a fuel inefficiently with not enough oxygen, then what you produce is carbon monoxide. And carbon monoxide is a primary air pollutant that is a criteria air pollutant. Now, by far the largest source of carbon monoxide is automobiles. The internal combustion engine is not a very efficient energy transfer machine. As we've said, you're only getting about 10% efficiency out of it. So a lot of the gas is burned insufficiently, and instead of making carbon dioxide, produces CO, carbon monoxide. Now, carbon monoxide is a pollutant because when you breathe it in, it binds to your red blood cells. Your red blood cells should be carrying oxygen around your body, but instead they bind with the carbon monoxide and they bind to it permanently. So normally oxygen joins to your hemoglobin on your red blood cell, it's carried around the body, and when it gets to your muscles the oxygen is released. If you breathe in carbon monoxide, it binds to the hemoglobin on your red blood cell, it travels around your body and stays bound to that hemoglobin. So your red blood cell now will not function to carry oxygen around. Now obviously in enclosed spaces, that will just build up the levels of carbon monoxide, and once you get a certain amount, your blood will no longer be carrying enough oxygen and you'll just suffocate and die. But even in small amounts, carbon monoxide can have a large impact on the body, decreasing your ability to carry oxygen to your tissues. Particulate matter is small particles. These are extremely small particles. So smoke is particulate matter. It's small particles that are big enough for you to physically see in the air. Now, very, very small particles, less than 10 microns, make up the standard that we're talking about for our criteria air pollutant. Now again, this is going to be a primary pollutant. When you burn things, you are generating your particles. When you do industrial processes, you may release particulates, small particles. So the EPA has a standard for particles smaller than 10 microns and 2.5 microns. So most of the 2.5 microns are definitely primary pollutants. Right? So that's going to be our smoke, and you've definitely seen this. If you look at a large truck, in our area we have large logging trucks, and they're stopped at a traffic light. When the truck pulls away, its diesel engine works really, really hard, and out the exhaust comes a huge plume of black smoke. There's our primary pollutant, 2.5 micron pollutant, criteria pollutant, coming out into the air. You can physically see it. So why are they bad? Well, they do accumulate in your lungs, and as they accumulate in your lungs, they start to degrade your alveoli, the actual surface of the lung that does gas exchange. Not only do they degrade it, they actually cause it to break down. They cause it to become inflamed, and just the swelling of the lungs means that the lungs work with less efficiency. So if you have a disease like asthma, this irritation of the lungs and swelling of the lungs will definitely inflame your asthma, cause your asthma to be more deadly. Now, it's not just on humans that we have the problem. Those same problems are caused in animals, but also on plants. These particles settle out onto the leaves of plants and act as a shade, decreasing the amount of sunlight that they can absorb. So if we have particulate pollution in an agricultural area, that shading of the leaves decreases the rate of photosynthesis and decreases the productivity of our agricultural crop. So it's not just health effects on animals we have to worry about, it's also health effects on plants. Sulfur dioxide is a compound that's produced when fossil fuels are burned. Most SO2, sulfur dioxide, is produced by burning coal. So about 70% of the SO2 released comes from our power plants. Now, SO2 would be a primary air pollutant because that's released directly into the air. Now, SO2, when it's in the air, will mix with water to produce a secondary pollutant, sulfuric acid. And this sulfuric acid is going to produce acid rain. Notice that sulfur pollutants are not just produced by humans. Natural pollution also is releasing sulfur into the atmosphere. So volcanoes release large amounts of sulfur every year. One thing that is true, though, is that we really can't prevent the pollution coming from volcanoes. And the pollution from volcanoes does not get worse as the human population increases on the planet. It does not get worse as the human population on the planet starts to use more technology. The fossil fuel use does increase as our population increases. Therefore, the fossil fuel amounts are increasing over time. The world population is increasing, therefore the amount of fossil fuels we use increases, therefore the amount of sulfur we're producing increases. So we're going to have to focus our efforts on reducing the anthropogenic pollution rather than the natural pollution. That does lead to an interesting question, though, and that question is, how much pollution is okay? I mean, if we're limiting our scope here to dealing with the anthropogenic pollution, then we're saying, hey, it's okay to have some pollution. All that natural stuff, that's fine. It's okay to cause some health effects. If it was not causing any health effect, it wouldn't be pollution at all. So what we're saying is some health effects are okay, but not this many health effects, not this amount of health effect. An interesting ethical debate over what is okay. How much of a problem are we going to put up with, and when do we say, no, that's causing too much health hazard? The oxide of nitrogens, the NOx's, are our next criteria air pollutant. And these are also formed when we burn fossil fuels. Now, nitrogen and oxygen molecules join together to make our NOx, with NO2 being the most common. And by far the most important source of nitrogen oxides is internal combustion engines. So cars and diesel engines are making large amounts of our NOx's. So again, that's coming right out, that's a primary pollutant. It is also produced when you do burn coal. Our local power plant exceeds its NOx pollution amounts most years. And often when you look at a power plant, if you have a coal burning power plant in your area and you look at its smokestack, if the smoke is coming out of its smokestack, drifting a short distance, and then has a really rusty tint to it, you can see that rusty color, that's actually the NOx's starting to react with the atmosphere. So that rusty color is mostly the nitrogen oxides that are in that smokestack, that effluent coming out of the plant. Once more, natural processes also produce large amount of nitrogen in the atmosphere. The interesting one here would be lightning. When lightning happens, it actually fuses some nitrogen and generates some NOx's in our atmosphere. And again, there's no way that we can actually try and remove the atmospheric effects of lightning. And those effects are somewhat helpful, because they convert nitrogen in the air into nitrogen that can pass into the soil and make it available for plants. So with our NOx's, some NOx's can be helpful, while others will lead to nitric acid, and that nitric acid will drop as acid rain. So again, we're going to focus on, well, how do we fix this? We've got to fix the fossil fuel area, because we don't want to decrease the amount of nitrogen flowing into our soils, because that's needed for plant growth, but we don't want it going in as NO2, which is being converted to nitric acid and then causing acid rain that would cause harm to our environment. The second reason why we don't really want fossil fuel production of NO2 is because even though the NO2 itself is a primary pollutant, when you concentrate it in city areas, it readily catalyzes the change of other molecules and itself into secondary pollutants. Now, NO2 therefore leads to the production of what's called photochemical smog. Photochemical smog is smog, air pollution, smoke and particles, as well as all the gases, so it's sort of like smoke and fog put together, smog, that is catalyzed by the fact that we have this NO2 in the air and large amounts of sunlight. And when we get these photochemical smogs, they dramatically increase the amount of ozone in an area and PAN in an area, and we'll see those two later. But so this problem with NO2 being produced by our industries in high density areas like our cities is that not only does it lead to acid rain, but within the city itself it leads to the development of secondary pollutants that cause photochemical smog. Lead is also a criteria air pollutant. Now, lead is a heavy metal that when taken into the body causes large-scale nervous damage. So it causes a large amount of damage to the nervous system, as well as having problems for your kidneys and your liver. Now, it used to be that lead was mostly released into the atmosphere because we put lead in our gasoline. We had leaded gasoline, and we also put lead in paint, particularly white paints. Now, when we banned the use of lead in gasoline and got rid of lead in paint, that has meant that lead has dramatically dropped in the atmosphere. There is still lead out there. There are a few countries that still use leaded gasoline, and in the United States there is still houses that are painted with lead-based paint. And when obviously that paint is removed, it can release the lead into the atmosphere again. But this is one where we do have quite a bit of a success story, where we are definitely pushing the amount of lead in the atmosphere down. VOCs, volatile organic compounds, are a huge group of pollutants. Right? They're also called hydrocarbons because they're made out of carbon and hydrogen molecules. And probably the best place for you to have seen VOCs is when you've been putting gasoline in your car. If you put the gas handle into your gas tank, squeeze it, and then just watch, you'll see that little shimmer coming out from around your filler pipe. It looks like the air almost has a heat shimmer to it, but that's the actual solvents coming out from the gasoline. So what you're doing there is you are releasing volatile organic compounds into the air. Every time you fill your lawnmower, you're releasing VOCs. Every time you fill your weed whacker, you're releasing VOCs. Every time you fill your car, you're releasing VOCs. So internal combustion engines account for a large amount of the volatile organic compounds released into the air. Solvents are the other piece. I'm sure at some point during grade school you'd use like Sharpie markers or other markers and you'd smell them and you'd be like, whoa, smell this pen. Well, if you can smell it, that's releasing a VOX. That is releasing the solvent off. Again, one of the major problems with VOX is that when they combine with NO2, they allow the production of secondary air pollutants in smog. So they're going to break down, they're going to be catalyzed with the NO2 and sunlight, and they're going to produce this photochemical smog within our cities. And the last criterion air pollutant, that would be ozone. So ozone is a molecule with 3 oxygen atoms. Normal oxygen is O2, ozone is O3. And there's 2 types of ozone. One type is called high-level ozone. And high-level ozone is ozone that's found in the stratosphere. That's up in the ozone oxygen layer, up in the stratosphere, shielding us from too much ultraviolet light. The second type of ozone is called low-level ozone, and low-level ozone is down in the troposphere, down in the area where we're walking around. Now, low-level ozone in smog is an incredibly dangerous molecule. It is extremely reactive. So when we have our VOX and we have our NO2, when you add sunlight to that, you get changes to produce secondary pollutants. And one of the main secondary pollutants is this low-level ozone. Low-level ozone is very corrosive. It will cause permanent lung damage. It will irritate the pipes that lead down to your lungs, your trachea and your bronchi. It will physically, chemically burn the inside of your tissues. It will damage the outside of your eye. Now remember that for humans, that's bad enough, but it doesn't just happen to humans, it's also happening to plants. So with the plants, they get taking those chemical burns as well, and as it oxidizes the chemicals on the plant, that's going to reduce the yields of our agriculture. And as we have lower agricultural yields, that means food supplies are decreased. So we've talked quite a bit about this idea of photochemical smog. It is not a pollutant in itself. Photochemical smog is just this mixture of pollutants that form when we get VOX, NOx's and sunlight concentrated in an area. And as we're actually producing this photochemical smog, there are 2 secondary pollutants that are the most destructive. The first one is ozone, that we also talked about, and the second one is called PAN, P-A-N, or peroxyacetyl nitrates. So PAN, peroxyacetyl nitrates, is also produced. To produce this ozone and this PAN, you've got to have your VOX, you've got to have your nitrogen oxides, and you've got to have sunlight. So in cities that are warm, in cities that are bright with sunlight, smog is a much higher problem. So therefore, high density cities that have warm summer temperatures and lots of summer sunlight are the areas that have the large amounts of smog, particularly if those cities are surrounded by mountains or in a valley, because the mountains and the valley prevent the air pollution from being blown away by the wind. It traps that air pollution within the city, and then once it's trapped within the city, the sunlight can change those chemical reactions, can start those chemical reactions and produce our secondary air pollutants. So in lots of cities, like Atlanta here in Georgia, you're going to have with your weather forecast a smog forecast as well. Right here on this slide you can see the chemical reactions that are produced in a bunch of these things. I'm not expecting you to be able to write these, but you should know, if you look down here, that what you've got is you've got your nitrogen oxides, your NO, NO2, you've got your VOX, your volatile organic compounds, and then the UV, that's the ultraviolet light, there's the sunlight. So what we're doing is we're converting nitrogen oxides into ozones and PAN, peroxyacetyl nitrate. There's the formation of our smog. So as we've said, the air pollutants that we've looked at so far are anthropogenic pollution. We're not focusing on the natural pollution, we're looking at the anthropogenic pollution. So how are we going to control the amount of pollutant that is released into the atmosphere? Now, the primary tool that we use is going to be the Clean Air Act. The Clean Air Act is a piece of legislation, a law, that says the EPA is responsible for developing and meeting air quality standards. So the EPA will determine how much of a pollutant can be released, and then set that standard and tell industry this is how much of this pollution factor that you may release into the air, and if you release more than that, then this is the fine that you're going to receive. So this is just a piece of legislation that allows a government agency, the EPA, to say this is how much pollution you can produce, and if you produce more than that, we're going to fine you. Has the Clean Air Act worked? Well, if you look at this graph, you can see that the amount of criterion air pollutants in the environment has dropped dramatically over the last 27-30 years. So it does appear that the Clean Air Act is having an impact on the amount of primary and secondary air pollutants found around our cities. Now, I do want to take a quick look at ways that the Clean Air Act has actually led to the development of pollution prevention technologies. So we're going to look at a few pollution prevention technologies that we actually have now. And the first one is going to be catalytic converters. So catalytic converters are now required on motor vehicles, and those catalytic converters remove NOx's from the emissions from the vehicle. So the catalytic converter is going to break down our NOx's into nitrogen and oxygen. And that nitrogen and oxygen are naturally parts of the air, so they're no longer pollutants. The catalytic converter also traps VOx and reduces the amount of VOx that are released out of the tailpipe of the car. So we're seeing a reduction in the amount of VOx coming out the tailpipes of cars. So catalytic converters have had a large impact on the air quality within our cities. Some of the impact that the catalytic converters have had, though, is being diminished by the increased number of vehicles. Each vehicle now produces much less pollution than it did 30 years ago. However, because the population is increasing, there are more cars on the road. So one of the problems we're facing is, with an ever-increasing number of cars, we're starting to see an increase in pollution once more. Right? So each car has to keep on getting cleaner and cleaner and cleaner if we're going to maintain the air quality that we have right now. Now, of course, we already talked about the lead and how just switching to lead-free gasoline had a huge impact on the improvement of air quality in terms of lead. So the federal government produced a law banning lead in gasoline. Boom, lead levels have decreased, and that's a nice simple example of how legislation can lead to an improvement. Now, the lead one was less painful than a lot of situations because we already had the technology to remove lead. Lead was an additive. It wasn't something that was naturally in the gasoline. We were deliberately putting it in there to help smooth the running of the engine, to help line the valve area so that the engine would last longer and run smoother. And we could just not put the lead in. It would have been much more difficult if it had been a substance that was naturally found in the gasoline, and would have been much more expensive if we would have had to deliberately produce a chemical process to remove the lead, rather than what happened when we just didn't add the lead to the gasoline anymore. Engineers have also reduced the amount of VOx that escaped from the gas tank of your car. they've produced much more efficient gas caps and much more efficient gas tanks, so that we are reducing the amount of VOC that will escape from the car while it's sitting there on a warm sunny day. And in some areas they've also improved the quality of the actual filler pipes. Right here we see a vacuum filler pipe. When this nozzle goes into the car, it is actually collecting any of the gases that pass out from the gas tank to be recycled down into the gas tank of the gas station. Here in Georgia we do not have these. Here in Georgia we still have just a metal pipe with just a splash shield on it. So if you live here in my area of Georgia, you can still see the VOCs escaping into the air. If you live in California, you won't see that, because California has stricter state laws that require them to vacuum up those VOCs and prevent them from entering the atmosphere. Particulate pollution is also regulated, and mining and farming, transfer of grain and coal by trains and trucks, and the production of dust all lead to particulate emissions, the release of particulate pollution. So we've taken steps to reduce particulate pollution. Some of them as simple as spraying water on the road when road work is being done. You'll often see this as you're driving down the interstate. There'll be a truck that's a non-potable water, a non-drinking water truck, just spraying water to prevent dust being blown up from the work area and generating particulate air pollution. Some of them more difficult than that would be burning wood generates large amounts of smoke. So if you have an area where wood stoves are a way of heating the home, then there could be local laws that ban wood burning stoves or require the wood burning stoves to have catalytic converters. When I grew up in England, all of the homes in the town were heated by burning coal. Everybody had a coal fireplace, and that generated large amounts of particulate air pollution. And what happened was they just banned the use of coal in homes. They just literally put a law in there that said, nope, you can't do this anymore. So everyone either had to pay a huge fine for maintaining their coal burning heater, or they had to switch to a much less polluting heater. And everyone that I knew switched to a natural gas source. So everyone switched from coal to natural gas, and you got a tax break for doing that. So it was a bit of a carrot and stick approach. The carrot being, hey, if you do this, you get a tax break. The stick being, if you don't do it, then we're going to fine you every year until you actually do it. And the whole community switched over from coal to either electric or natural gas heating, and the air quality was improved dramatically. So notice that there is right here an infringement on rights, and in the United States that's also got to be taken into account. Do you have the right to heat your home in any way you wish, even if by doing so you harm the health of other individuals? Or does the health of the community mean that their right to have healthy lungs and good air quality supersedes your right to want to heat your home with a wood burning stove? Now, this is a moral decision, an ethical decision that each person has to decide on for themselves, and I'm not going to sit in class and say, hey, this is right, this is wrong. But it is a decision that you need to be able to discuss. Is the right of the community to have clean air equal to, greater than, or less than the right of an individual to decide how they want to heat their home? The EPA is not just working with individuals, it's also working with major companies such as Southern Company. Southern Company is the parent company of Georgia Power, and Georgia Power owns all the power plants around Georgia Military College. So the EPA has to work with these major companies to try and reduce their air pollution as well. So we've already said that power plants produce large amounts of sulfur dioxides. If they're burning coal, they'd also produce particulate pollution. So how are power plants going to reduce the amount of air pollution that they produce? The Clean Air Act says that the EPA can say you must reduce your pollution by XYZ amount, but how does the power plant actually go about doing that? One way is the use of filters and scrubbers. So if you're trying to reduce particulate pollution, there are two major types of filter that are used. The first one is called a bag filter or a bag house filter. It's seen at the top of the slide here. Now, if you've ever changed the bag on a vacuum cleaner, you know how a vacuum cleaner works. There's like a paper type bag. Inside the vacuum cleaner, the air's sucked through that bag and the bag filters out any particles that are in there. Well, a bag house filter basically works the same way. It's a house-sized filter, hence the bag house name. And inside that house are rows upon rows of bags, and the bags filter out the particles. So the air comes from the fire into the baghouse filter, passes through the filters, and then goes to the exhaust before going out the chimney at the power plant. So these bags, just like the bags inside your vacuum cleaner, fill up with particles. Now as they fill up with particles, they become less and less efficient until at some point they're clogged and they won't work anymore. So this efficiency is definitely a problem. So you can't just have a single baghouse filter, you have to have multiple filters around the power plant, so when one becomes clogged you can turn it off and utilize the other filter. So this is a really old simple technology. If we have it in our houses for vacuum cleaning, obviously it's not the most efficient. Further down at the bottom of the page we have a second type. This is called an electrostatic precipitator. And you won't have one of these in your home probably, but you'll definitely have something in your home that works this way. Your TV screen or your computer screen clogs with dust, just seems to suck dust out of the air because it sucks dust out of the air. This charge on the screen means that it attracts dust. So an electrostatic precipitator is just a series of electric plates inside the flue of the power plant, and those electric plates have a charge, a positive charge or a negative charge, and that charge attracts the dust, the particulate matter, and the particulate matter just sticks to the plate. Now every so often they just reverse that polarity and give it a big shake, and out drops the dust to be collected. So if you have an ionic breeze air filter, this is working exactly the same way. So electrostatic precipitators don't have a bag that can get clogged, so these things don't clog like a baghouse system, but they do decrease the amount of particulate pollution coming out of the power plant. So here's just a picture of a bunch of electrostatic precipitators that are going to lead to the actual chimney of the power plant. So as the dirty air is passing through these electrostatic precipitators, the particulate pollution is being filtered from the air, so when the air is actually released it's much cleaner. Removing sulfur is a little bit more difficult and is a lot more expensive. Now probably the simplest way to reduce the amount of sulfur is to just burn coal that's low in sulfur. So the use of low sulfur coal will have a large impact on the amount of sulfur a power plant releases. Now, we already said earlier that these things have an impact on cost. Low sulfur coal is more expensive than high sulfur coal. So when we switch to low sulfur coal, that does mean that the cost of producing electricity is more expensive, and therefore the cost of buying that electricity to use in your house is going to go up. So it's one of these catch-22 situations. If you want your air to be cleaner, then your electricity provider needs to use a cleaner fuel, and by using a cleaner fuel that gets more expensive, so electricity becomes more expensive. So if you want your air to be clean, you're going to be paying more for your electricity. What do you want? Cheap electricity or clean air? Now, if you want to be even cleaner than just switching to low sulfur coal, you could switch to a completely other fuel source. You can switch to a natural gas plant. Natural gas doesn't produce any SOXs. Or you could switch to nuclear energy, which is a lot more expensive but nowhere near as polluting. Or you could switch to a renewable energy source. So this lecture comes after our energy lecture for a reason. If you switched to renewable energy, by switching to renewable energy, you also fix your air pollution problems. If you are producing your electricity using a non-polluting form, hydroelectric, wind power, solar power, then you're using vehicles that are also running on electricity. You get rid of large amounts of air pollution in the same step. So you gain sustainability in terms of how long your energy supplies will last. You gain national security because those energy supplies are all within your own borders, and you gain air quality. So switching from a non-renewable resource to a renewable resource not only has implications for the energy security of the nation, it also helps improve the air quality of the nation. I do have to point out that it's all not rosy, because the investment in research into how to do renewable fuels and the investment in infrastructure to build renewable fuel power plants and distribution services is going to cost you money. So there's no way around this that you can do it for cheap. If you're going to have to improve air quality, then you're going to have to spend more money. One last way is, if you still want to use the coal, then let's try and scrub it from the smokestack. Let's try and clean the sulfur after it's been produced. Now, there are scrubbers that utilize chemicals to remove sulfur, however they are extremely expensive. Our local power plant is called Plant Branch, and it is having problems with the amount of pollution that it's producing. And they do have some scrubbers on there. However, to meet their permit requirements, they're going to have to upgrade all of their sulfur and nitrogen scrubbers. And the power company have decided that they're just going to shut the plant because they say it's too costly to clean the pollutants from the air to install the new scrubbers for the amount of electricity that they're producing. So they're just going to shut the plant. And as they shut that plant, it would be great if we were replacing it with a non-coal burning power plant. That doesn't seem to be the case. It seems to be the case that all they're going to do is close this plant and then use other plants that are slightly more modern to generate more electricity just by burning more coal at those plants. So again, we hit this ethical dilemma. We want our air to be clean, but if you put your standards so high a company cannot afford to actually meet them, then you harm your economy by closing work sites, by shutting down factories, by closing power plants, and removing a bunch of people from the workforce. So we have to end up with a balancing act. We have to produce a sustainable society. And to have a sustainable society, we need to have society with an economy that functions with jobs for people. And at the same time, we need to have a clean environment. And balancing those two is an incredibly difficult thing. And as an individual who gets to vote, who gets to express their opinion to their legislator, you need to decide where on this line of responsibility you are. Are you completely for the anthropogenic viewpoint where the environment is there for human use and human use only? Or are you more on the ecocentric side where no, we should keep the environment clean because we owe that to future generations and the other plants and animals around us. You've got to make those decisions and come down on where you feel you are on the Clean Air Act and on strengthening or weakening the role of the EPA.